In 2040, the world will look dramatically different due to multiple technological advancements. For example, the metaverse will become fundamental to everyday life. By 2040, multiple large tech companies will make significant contributions to the metaverse, and the metaverse will gain widespread appeal among people of most age groups and demographics. More than likely, the average person will use the metaverse and hardware components associated with it as much as people use the internet and smartphones today. The average person in 2040 could have a highly detailed and realistic 3D avatar with several preset outfits, along with hundreds or thousands of individual clothing items to choose from. They could have a decorated 3D home space containing doorways to the bookmarked metaverse worlds. And they could have a 3D virtual work environment with a custom arrangement of apps that are tailored to work optimally in a metaverse environment. Digital assets could be accessible across multiple devices such as virtual reality headsets, augmented reality glasses, smartphones, smartwatches, and so on. And those assets could be accessible in multiple apps that were typically considered unrelated to each other in earlier decades. There could be a wide variety of virtual environments in the metaverse that each serve a different use case beyond just entertainment. Those use cases would include fitness, education, job and career training, product demonstrations, virtual keynote speeches, marketplaces to buy virtual and physical items, and more. Additionally, we could have user-generated location-specific holograms overlaid in most major cities and institutions to provide navigation, reviews, and 3D animations of past events. Number 2, brain-computer interfaces could become mainstream. Technologist and futurist Ray Kurzweil predicted that in the mid-2030s, we could begin connecting the human neocortex to the cloud. By 2040, that prediction could come true. Brain-computer interfaces could vastly improve over the versions from 2030, and they could be largely usable for everyday purposes. They could also become standard accessories for virtual reality headsets, including high-priced VR helmets that offer full-dive VR experiences. And some brain-computer interfaces could be fully implantable for medical purposes. When it comes to entertainment, people can use brain-computer interfaces to control objects in video games and virtual environments with high, reasonable accuracy. Video game studios could begin to integrate this technology into their video games. For example, the ability to control objects with your thoughts would be particularly relevant in the Star Wars game, where you play Jedis and Siths with Force abilities, and in the Matrix game, where you play as the One. However, brain-computer interfaces could make the most substantial impact when it comes to serving those with spinal cord injuries, whereby patients can regain motor control and control over their senses. Number 3, lifelike virtual assistants could become mainstream. By 2040, each person could have access to a digital virtual assistant. By this point, language models similar to GPT-3 are exponentially more advanced, and virtual assistants could be built on those language model platforms. These virtual assistants could be trained on text data and maybe even the image data from the majority of websites and publications ever created in human history, so they could be able to answer almost any question we ask to them. And their answers could be personalized based on our goals, interests, and career paths. They could constantly predict what we might want to do next and make suggestions throughout each day instead of us having to type phrases into search engines. And they could be represented as 3D virtual characters that we can contact from most virtual environments and in the form of holograms when using augmented reality devices. These virtual characters could have their own complex and unique personalities, appearances, voices, and special abilities that we can customize as needed. Number 4, Level 5 autonomous vehicles could emerge. By 2040, autonomous vehicles could operate without human intervention at all. However, the main factor that would accelerate this development would be cities and districts that are specifically built to support Level 5 autonomous vehicles. This could involve delegating specific parts of a city for autonomous vehicles and specific parts for pedestrians to reduce the chance of accidents. It could also involve building roads embedded with sensors so that the location of each autonomous vehicle is tracked in an interconnected network. And as these types of networks evolve, they would track all vehicles, stoplights, street conditions, and more to form the basis of the world's first smart cities. Number 5, quantum computers could become available to the mainstream public, both via the cloud and as physical units. This advancement could revolutionize how we solve optimization problems, train and run machine learning algorithms, and better understand the physical processes of nature down to the subatomic level. The industries that could get the most benefit from it are finance, pharmaceuticals, cybersecurity, and material science. Number 6, artificial intelligence could take over the education industry. By 2040, AI could take over significant parts of the education system. AI teachers could start to emerge, which students can access using virtual reality and augmented reality devices. AI teachers could offer personalized education based on information provided to them and based on verbal and physical cues. For example, an AI teacher can notice what makes a student's pupils dilate and alter the way it teaches to keep that student engaged. If a student loves basketball, AI teachers could rewrite math and English problems so that those problems are tailored to the basketball domain. and AI could give a different homework assignment to each student based on his or her pace. AI teachers would lower all basic costs in the educational system and allow more people to access high quality and standardized education. And in wealthy communities, human teachers can take on fewer students in order to become their personal mentors and coaches. Number 7. Service robots could number 1 billion worldwide. By the mid-2030s, the number of service robots could reach 1 billion worldwide and continue to grow rapidly. Service robots could be generally divided into two separate groups, personal and professional. Types of personal robots would include vacuum cleaners, lawnmowers, toys, personal mobility machines, and pet exercise robots. Professional service robots would be used for commercial purposes and normally operated and monitored by properly trained personnel. Examples can include medical robots performing surgical operations, firefighting robots, automated security patrols, machines to clean public places, delivery robots, and so on. Industrial robots would also play a big part in society, especially when it comes to manufacturing, but they'll be nowhere as numerous as the first two types. At this stage, most robots can instantly recognize and interact with countless objects while providing real-time information to customers. And because of these robots, manufacturing jobs in the United States will have largely disappeared. All of this could be made possible due to exponential improvements in machine learning, cloud computing, bandwidth, sensor technology, and so on. Number 8. The first permanent lunar base could be established. By the later half of the 1930s, government and private ventures could create a permanent human presence on the moon. This milestone would be partially motivated by the planned development of the asteroid mining industry, which could generate trillions of dollars of revenues over the coming decades. 3D printing would make the construction of this lunar base much cheaper and easier than alternative methods. New tools, spare parts, and components for entire buildings could be forged using rock and dust on the moon's surface. This lunar base could be led by NASA, with contributions from the European Space Agency, Canadian Space Agency, and various private companies. China may also prepare its own separate lunar base in collaboration with Russia. Number 9. Hypersonic airliners could enter service. Following decades of research and development, a new generation of airliners could enter commercial service. This aircraft could have a cruising speed of Mach 5, which is more than 7 times faster than a typical passenger jet, and 5 times the speed of sound. Hypersonic planes can fly from New York to California in 30 minutes, and they can fly from New York to London in under 4 hours. Their advantages are numerous. They can be lighter than Boeing 747s and utilize conventional runways. Additionally, they would make moderate takeoff noise. The only disadvantage is that they would lack windows because windows would be too heavy for this type of aircraft. One solution to this problem could be the installation of flat screen displays that show footage of the world outside. Number 10. CRISPR and gene therapies could greatly minimize diseases. Technologies and approaches such as CRISPR, gene therapies, 3D printed organs and blood vessels, nanoparticles, and nanorobots could minimize diseases in ways that were unthinkable only a couple of decades earlier. A vast range of infectious diseases, including AIDS and Ebola, could become curable. Genetic ailments like sickle cell anemia and certain forms of blindness could become curable as well. 5-year survival rates could reach 100% for certain forms of cancer and heart disease thanks to gene therapy, and annual deaths from cardiovascular disease could reach negligible levels in the US. Number 11. Moon and asteroid mining could become a routine practice. By 2040, the utilization of space resources such as metals and minerals from the moon and asteroids could become the next big thing in commercial space ventures. It could also become a major growth area in terms of innovation and wealth creation. By 2040, asteroid mining could account for only a tiny fraction of global commodities. However, it's widely expected to comprise a substantial percentage of the commodities market in the coming decades. Thanks to moon and asteroid mining and unrestrained hype in the stock market, a well-known American business tycoon could become the world's first trillionaire before 2040. Number 12. Carbon nanotubes could begin production. After decades of research, new processes could be developed for synthesizing carbon nanotubes. Carbon nanotubes are tubes made of carbon with diameters at the nanometer scale. A nanotube can consist of either a single sheet of carbon atoms or multiple layers wrapped to form a hollow core. These structures can reach potentially thousands of miles in length. They're also capable of being hundreds of times stronger than steel. The use cases for carbon nanotubes are numerous. They include bulletproof vests, water-resistant clothing, lightweight composites for automobiles, planes, and spacecraft, radiation shield materials, next-generation materials for transistors, and water purification. Some people could even say that it makes a space elevator possible as well. Number 13. The first zettascale supercomputer could be operational. In 2040, a supercomputer at the zettascale would be 1 million times more powerful than the fastest supercomputer in the early 2020s. This system would be data-centric, meaning it would be optimized to handle extremely large volumes of data. It could also be decentralized, meaning it would be comprised of millions of less powerful components linked and working together to form a collective hypercomputer that is more powerful than any single machine. Number 14, the Einstein telescope could be operational. The Einstein telescope is a third-generation gravitational wave observatory developed by research institutions in the European Union. It has 10 times the sensitivity of any previous instrument, which greatly increases the distance at which black hole collisions, neutron stars, dark matter, and other gravitational wave sources can be analyzed. It would also improve tests of Einstein's general theory of relativity. Additionally, the previous generation of gravitational wave observatories only studied the universe at a 10 billion light-years distance. The Einstein telescope is able to look even further back in time to what they call the cosmic dark ages, when the first stars and galaxies began to form. Number 15, robots could dominate the battlefield. Highly mobile, autonomous fighting machines could be deployed with the majority of frontline military personnel. Because of their advanced machine vision, they could aim with inhuman precision, and they could have superior situational awareness due to their powerful sensors, GPS, and thermal vision. No human would have any chance of defeating it using conventional approaches, and these machines can be deployed for weeks or months at a time, if necessary, without the need for maintenance. Number 16, space-based solar power could become commercially feasible. By 2040, energy generated from space-based solar power could be added to many power grids. This system involves placing several large satellites into Earth's orbit. Each satellite would have a large nanotech-based surface for a solar array that is almost 2 miles in size. These solar arrays would capture the energy of the sunlight, which is then beamed down to Earth via lasers. Large collecting dishes on the ground would receive the energy and convert it to usable electricity. One major advantage to this approach is the fact that these satellites can be exposed to sunlight 24/7 instead of just 12 hours a day like ground-based panels. Because of space debris, the panels would require high-strength shielding. Also, some of the high-tech panels could use a nanotechnology-based composite to self-heal whenever damage occurs. It's expected that these types of satellites could appear in orbit around the Moon and Mars to provide energy to human bases. And over the next 2 centuries, enough of these satellites could eventually orbit the Earth so that virtually all of the sunlight is captured and harvested in some way. This is also an important step for humanity to become a Type 1 civilization. A Type 1 civilization can use and store all of the energy available on this planet. Number 17, deep ocean mining operations will likely become commonplace. Thanks to advances in robotics, it would be possible to mine for materials on the ocean floor. By 2040, prospecting and undersea construction will be done using fleets of automated and remote-controlled robots. When ships or mining platforms are positioned above an area of interest, resources will be brought to the surface through hydraulic suction or continuous bucket line systems. The primary focus of these operations would be to obtain rare earth metals to be used as materials for a wide range of electronics and other high-tech applications. If there are global shortages in 2040, these resources could be on the same level of strategic importance as oil and natural gas from earlier decades. Another valuable, although hazardous target of deep ocean mining is methane hydrate. Methane hydrate is the largest natural gas resource on planet Earth. Deposits for methane hydrate consist of concentrated methane trapped within crystals of frozen water. Japan, China, and the United States have already established the largest mining operations to mine for this energy source. Number 18, fusion power could become commercially available. The world's largest fusion power project, known as the International Thermonuclear Experimental Reactor, could become functional in the mid-2030s. It could produce a sustained output of 500 million watts, which is comparable to the energy output of a typical power plant. The advantages of fusion power are that it's inexpensive and abundant in nature, and the amount of long-lived radioactive waste and greenhouse gases produced throughout fusion are minimal. Additionally, by 2040, a new experimental reactor called SPARC could be developed by MIT and a spin-off company called Commonwealth Fusion Systems. Number 19, the Very Large Hadron Collider could become operational. By smashing particles together in high-energy collisions, it's possible to recreate the conditions in the earliest moments of the universe. The higher the energy, the further back in time researchers can simulate, and the more likely it is that exotic interactions could be observed. The Very Large Hadron Collider will be the successor to the Large Hadron Collider, and it could be built in the mid-2030s. Its accelerator ring will be about 62 miles around, and it would run at 7 times the energy of the Large Hadron Collider. The purpose of it is to vastly improve our knowledge about the Higgs boson particle, dark matter, dark energy, and string theory. In the long run, this new collider could help with the development of pico technology, which enables technological manipulation of matter that is 3 orders of magnitude smaller than nanotechnology. Number 20, the High Definition Space Telescope could be operational. By 2040, the High Definition Space Telescope would be designed to locate dozens of Earth-like planets in our solar interstellar neighborhood, which is just a small section of our Milky Way galaxy. The High Definition Space Telescope would be 100 times more sensitive than the Hubble telescope, and it would be equipped with an internal coronagraph, a disk that blocks light from a central star in the solar system, which makes a dark and hard to see planet more visible in that solar system. It's also expected to take photos of the planets and moons in our own solar system with spectacular resolution and detail. Thanks for watching. Make sure to watch this next video about future technologies in the year 2050.